Yes, so let's continue our discussion on sound waves, and this is lecture number 3. We have done the discussion on displacement wave, pressure wave, and this density wave, and we have done the discussion on speed of a longitudinal wave and the bulk modulus and those things. There are a few very important topics remaining, like intensity of a wave, standing waves, organ pipes, and Doppler effect. So we'll start with intensity today. Intensity of a sound wave. For this, remind me, what is the formula of intensity of a wave? What was the general formula? Intensity of a sound wave. Half rho omega square a square v. That's the velocity of the wave. S gets cancelled when you take pressure upon area. Yes, this is the general formula that you just have to remember. And then we can modify this formula in many ways. We can write A in terms of delta P max, because we have a luxury of writing in delta P max as well. What was the formula of that relates delta P max and A? Delta P max is equal to BAK. Let's say I want to eliminate omega, then V equal to omega by K, then omega equal to V by K, kya? Yes? So V is equal to omega by K, then K is equal to omega by V. So this will be BA omega by V, and then what will be omega? Delta P max V by BA. If I make this substitution, then what will my intensity become? That's half rho omega square a square, rather omega ke jagah pe delta P max square V square divided by B square a square V. So I think this a square gets cancelled. Yes, and what is the formula that you get? Half rho V cube by B square delta P max square. This is another formula. That these are just interchangeable formulas. If you know these relations, then you can play around with them any way you want. We have a relation between B, rho and V as well, and what was that? So I have a relation between B, rho and V. Velocity is equal to under root B by rho. Then what is B? That's rho V square. So I can equally write one more thing, that's intensity is half rho V cube by rho square V power 4 delta P max square, and then I will get a relation that intensity is half, I think this will get cancelled, 1 by 2 rho V delta P max square. So all these relations are equivalent to each other. You can play around and find anything based on the question that is given. If bulk modulus is not given, then you can apply this formula. If it is given, then you can apply this or the other, whatever. So everyone has written till here. This is the intensity of a sound wave. I will wait 1 minute and then I will go on. Jaldi likho. I told you to sit there, na? Achha, just for fun, can somebody tell me what is the range of the audible range that a human ear can detect? 20 hertz to 20 kilohertz, such a huge range, na? And that means this intensity range in general will be a huge range as well. It depends on frequency in one way or the other, na? Yes, so the range will be a huge thing. So if I say that the rustling of leaves, do you know the rustling यानी कि if a wind comes तो थोड़ा थोड़ा leaves हिलते हैं, that noise and the noise of the thunder, can you comprehend the difference between them? Maybe the thunder के tens of thousands of kilohertz है कुछ तो 10 kilohertz है या ऐसा कुछ, then the intensity will be totally different, and the intensity of the sound wave which is coming from the rustling of leaves will be totally different. The range, the difference will be so huge, na? How to comprehend that? How to comprehend such a huge difference? For that we can do one thing. What if we scale it down? What if we scale our intensity down so that we can comprehend things? And what do I mean by that? Is, let's say I have a number. How to scale down a number? Any function that does it? Log. Log function does this thing where if you have 10 power 5 as an input, what is the output? 5. And let's say I have an input which is 10, then what is the answer? 1. Can you see that the range has decreased so much? Your input range was so huge, but now you have scaled it down. So a function which helps in scaling down things is a logarithmic function. Okay? So we will try to use this logarithm to scale down the this intensity range, and that's called writing the intensity in decibels. So sound intensity in decibels, and it is given as, so obviously it will be dependent on log of intensity. Yes, but let me put a factor of 10 in front of it, and I am going to take a reference value, and let's call it I0, and this is the formula of sound intensity in decibels. Yes, dB. This is decibel. So, and what is that I0 reference value? That is the minimum possible value that a human ear can detect. Okay? So let's I0 is equal to a reference value, and this is the minimum possible intensity of sound that human ear can detect. And what is the value of it? It's power minus 12. Yes, it's watt per meter square. 10 power minus 12 watt per meter square. That is my least possible intensity that a human ear can detect. Okay? So this is I0. Now let me give you an example just for so that you get a feeling of what this decibel scale is talking about. In terms of decibel scale, rustling of leaves, this has an intensity of 10 decibel, around 10 decibel, and the sound of a thunder, the intensity of that is somewhere around 110 decibel. So it's still comprehensible. You can comprehend this. Yes, 10 decibel, 110 decibel. The range is not that much. Yes, that's why we introduced decibel scale. Is it okay? Is there any problem in this? This is just for example. Good. Now there are some terms that you should know, like the I think it's called the threshold of hearing and threshold of pain. So threshold of hearing is the minimum possible value that you can hear, and that's I0, na? So threshold of hearing, you can't hear sound with an intensity which is less than this. This is the threshold. Iske upar hi you can hear it. Okay? So threshold of hearing. Everyone understands the meaning of threshold, na? It's the minimum possible value. Threshold of hearing is I0. Acha, when your I equal to I naught, then what is my beta? What is my beta? That's 0 decibels. Yes, because I equal to I naught, log to the base 10 1 is 0. So what is beta? So we have made our scale in such a way that it starts from 0 decibels. Okay? That is why I put a I naught here. Do you understand? Okay. And what is the threshold of pain? Yes. Threshold of pain, its intensity is given to be I, which is equal to 10 power 1 watt per meter square. Na?
So what is the measure of pain?
Pain. Beyond this, I think your ear lobes will पड़ जाएंगे. ठीक है? And that is what decibels? How much decibel will it be? I think 120. है ना? Even more than the sound of a thunder. So beta will be 120 here. Is it okay? Is it okay? Everything that I've written.
Generally, stadiums and all 120 decibels is generally recorded section. So why
Huh?
the ears are getting damaged?
Your ears are getting damaged.
In stadiums and all,
There you are getting damaged. It's not like you come out of it unscathed. ठीक है? It's just your adrenaline is so high that you don't realize it. Anyways, the threshold of pain, this is okay. These are some common terminologies, ठीक है? That you should know. Good. This is beta, and let's say I want to find there are two sources of sound, and they are giving off intensity I1 and I2. Then what is the difference between the intensities? Let's say the beta 1 is given as 10 log to the base 10 I1 by I naught, and beta 2 is 10 log to the base 10 I2 by I naught. Then what is beta 2 minus beta 1?
I2 by 10 log to the base 10, I2 by
Yes, this will be 10 log to the base 10 I2 by I1. Na? Everybody knows the properties of log. Log of a by b is log a minus log b, and you get this result. Is it okay? This is comparing the intensities of two different sources, maybe, or maybe from the same source at different locations, because the intensity keeps on dropping. Na? Is it okay? If you have understood the theory part, then we can start with some problems. So let me write a question. Everyone has written till here? Okay, attempt. So I am giving you 3 minutes to think and then I will start. It's okay, leave it. If it's not coming, it's okay. Yeah. So I will start at 12:21. Huh? Bolo.
Are you converting the maximum values to like this, 10 decibels, something decibels, how are you doing the translation?
How am I doing it? इंटेंसिटी की वैल्यू इधर सब्सटीट्यूट करो, लॉग निकालो, वैल्यू आ जाएगा.
What is I naught then?
आई नॉट दिया तो है, -2 नहीं है बेटा, -12 है.
So anything by 10 power minus 12.
हाँ, एंड देन लॉग लो. Any answers? Should I start? There's only 1 minute left. Okay then, I'm starting with the question. They are asking to find the intensity in watt per meter square ना. हाँ, कोई आंसर आया?
Value of log 7.
log 7? नहीं, log 7 तो नहीं आना चाहिए कहीं से भी.
416.
नहीं.
So 40 decibels.
No. Let's see. you have to find the intensity and some information about delta P max is given. 6 into 10 power minus 5 पास्कल. डेसिबल में कैसे आ रहा है? वाट पर मीटर स्क्वायर में आंसर निकालना है. क्या कर रही है? उसके बाद रो ऑफ एयर दिया हुआ है आई थिंक 1.2 दिस एंड देन वेलोसिटी ऑफ साउंड दिया हुआ है. You can use that frequency का data, but I will not use it. I will go with the simplest possible formula of intensity. What was the simplest possible one out of all of them? ये सबसे simple वाला यही लग रहा है ना. 1/2 rho v delta p. सबसे least number of terms इसी में मुझे लग रहा है, जिसमें क्यूब स्क्वायर ये सब कुछ भी नहीं है. ठीक है. 1/2 rho v delta p max square. तो let's use that. तो intensity is 1/2 rho v delta p max square. delta p max square हो जाएगा 36 10 power minus 10. ये 2 rho 1.2 v 344. तब 12 ones are 12 threes are, that's actually 30 है ना. 36 divided by 1.2 और ये 2 ones are 2 15. तो ये 15 डिवाइडेड बाई 344 इंटू 10 पावर माइनस 10 हो गया. अब ये 344 को 345 अप्रॉक्सीमेट करते हैं. ठीक है, जस्ट टू मेक माई लाइफ ईजियर. और इसको फिर क्या हो जाएगा फिर बताओ. 5 के टेबल से जा रहा है, 15 के टेबल से भी जा रहा है आई थिंक. 15 ones are 15 23s are. ठीक है. And let's multiply and divide by 100 so that it will become 100 divided by 23 into 10 power minus 12. And then 100 divided by 23 तो बहुत सिंपल है ना. 4.34 मुझे लग रहा है. करके दिखाऊं? है ना. 4 3 से 12 92 8 बचा, पॉइंट लगाओ 83. यस 4.34 अप्रॉक्सीमेट करो. नहीं यार 4.34 आएगा कुछ तो, ये चलते जाएगा, छोड़ो. 4.34 एंड पावर माइनस 12. आंसर इज 4.4. तो अच्छा ही है मेरा आंसर, एक्चुअल आंसर. ठीक है. एनीवेज 4.6 आ रहा है. अच्छा, और उसके बाद पावर कुछ बोला नहीं. पावर छोड़ो, तुमने यूनिट्स भी नहीं बोला. यूनिट्स के अलावा तो सब आंसर रॉन्ग ही है मेरे लिए, वरना मैं किलोमीटर्स मानूंगा इसे. समझे? इफ यू आर डन विद इट देन कैन आई गिव यू द नेक्स्ट क्वेश्चन. अच्छा, yesterday did I give a reasoning of rho moist and rho air? I told you rho moist is less than rho air, ऐसा कुछ तो बोला था ना मैंने. वो गलत रीजनिंग, वो नहीं था. द थिंग इज कि रो मॉइस्ट में H2O मॉलिक्यूल ज़्यादा होते थे. एंड व्हाट इज द मोलर मास ऑफ H2O? 16 होएगा. 18, चलो छोड़ो 18 होएगा. 18 होएगा. और ड्राई एयर में N2 मॉलिक्यूल O2 मॉलिक्यूल एग्जिस्ट करते हैं, N2O2, और इनके मोलर मास ज़्यादा होते हैं कंपेरेटिवली. तो इसलिए इसका ड्राई एयर का डेंसिटी ज़्यादा है. समझे? क्या माइनस बोला था? कौन सा माइनस? अरे वो तो मैंने नहीं देखा, ये देखा मैंने तो ये बता दिया. ठीक है. वो एक्चुअली मैंने कंडीशन तब मैंने अज्यूम कर ली जब टेम्परेचर डिक्रीज होते जा रहा है. टेम्परेचर वॉज नॉट डिक्रीजिंग. यू टेक अ कॉन्स्टेंट टेम्परेचर एंड देन कंपेयर. सही है, सही है. इज इट ओके नाउ? गुड. क्वेश्चन नंबर 2. ये तो इरेज कर दे, तो ये तो बच्चा बच्चा कर लेगा. This is mentioned. Now attempt the question. अरे अकेले जा रहे हो? I will give you 3 minutes, then I will start. I will try to post this rotational videos on Sundays, okay? कल 2 lecture hopefully I will post if I don't sleep, if I don't oversleep. आंसर आ रहा है किसी को? 4.1 इनकरेक्ट. Incorrect. क्या करें? शुड आई स्टार्ट? नो. One person is saying no. How many of you say yes? Should I wait a little longer? No. One हुआ है. और बताओ, any other opinions? Wait. Should I start? Huh? No. Wait. Very good. 3 versus 1 का बेटा चल रहा है. करो, अटेम्प्ट करो. अरे बाप रे, 5 डिजिट की 6 डिजिट पर चला गया. एक और इनकरेक्ट. ठीक है, लेट मी स्टार्ट विद इट देन. It's given that the source of sound emits a constant power. Okay, अच्छा, let me make the diagram and then you tell me. Let's say this is a source of sound. It gives off waves in all possible directions. So it gives off waves like this, like this, like this, in all possible directions. And if I connect all these locus, what will I get? Will I get a circle? I made a 2D projection of the actual figure. What is the actual figure? It's a sphere. A sphere, and it has, let's say, a radius of r. Okay. Then what is the intensity का basic formula? The basic formula is intensity is power by area. Yes, and what is the area of this sphere? 4 pi r square. तो बताओ, what are the things given to be constant? This whole thing is a constant. Then what is the intensity proportional to be? It's inversely proportional to r square. This is one thing. Okay. Using this, we will try to find everything. How? They have said कि when you try to go from one point, let's say you are standing here, somewhere here, this is my source. You are standing at a distance x at point P1, and now you went to a distance of 2x at point P2. Then what will be the intensity drop? There will be an intensity drop now as you go away from the source. What will be the intensity drop? So it's like finding the intensity here and then subtracting from there. So it follows that formula, na? What formula? Beta 2 minus beta 1 is log to the base 10 I2 by I1, where 2 is the intensity at point P2 and 1 is the intensity at point P1. So I2 by I1, how to find this? Intensity inversely proportional to r square. I2 by I1 is r1 by r2 the whole square. And what is the distance of r1? That's x. What about there? That's 2x. So that becomes 1 by 4 kya? Please check. Yes? Then what is the beta 2 minus beta 1? 10 log to the base 10, 1 by 4. अच्छा, log की property क्या पता है? Log of a by b is minus of log of b by a. You know this? So this becomes minus 10 log to the base 10, 4. Log की एक और property होती है. This 4 can be written as 2 square. तो 2 आगे आ जाएगा. This will become minus 20 log to the base 10, 2. अब बताओ log to the base 10, 2 कितना होता है? 0.3. इसे 0.3 ले ले. 0.3 ले लेंगे तो फिर ये कितना हो जाएगा बताओ? -6 decibels. Is it okay? Copy.
The minus sign indicates the drop.
There's a drop. If you were to take beta 1 minus beta 2, you will get positive. So I'm not going further than this in questions. You can find many questions in your modules. Attempt those, and if you find it difficult, then ask me. Okay? For now, I'm moving forward with the theory. So, is it done? Please write fast. And if you have understood, then try to do it yourself. We have talked about formation of stationary waves in the when we were talking about transverse waves. Now I will try to find a theory of formation of stationary waves by sound waves, and sound waves are longitudinal waves, na? So we will try to do that, and essentially the theory is exactly the same, so I will not repeat most of the part. I will just skip through it and I will write the important formulas only. Is it okay? So is it done? Interference of stationary interference of sound waves. Take the topic. Of sound waves and formation of stationary waves. Yes? Earlier we used to take two waves of the form like this, ना? ऐसा एक लेते थे y1 is equal to a. अच्छा, what are the necessary features you should have to form a stationary wave? What are the necessary things? Given two waves, what are the necessary things? बोलो भाई, simple चीज़ है ये तो. They should come out of coherent sources. They should come out of coherent sources, and very basic thing would be if one of them is kx minus omega t, then the other has to be kx plus omega t. They have to come from different opposite directions and then meet. Yes or no? So earlier we used to write a cos kx minus omega t, and the other one would be a cos kx plus omega t. But we used to do this discussion and then find the yr, which was y1 plus y2, है ना? By superposition principle. But that was a discussion in transverse wave. Now we have the luxury of writing it in pressure variation as well, na? Pressure wave we also know. What will be the pressure wave? If this is cos, then other should be? Should it be cos again? Why sine?
That is
What is that? Huh? What is the main thing between between a pressure wave and displacement wave? Main difference. The phase difference is what? Pi by 2. That's pi by 2. So cos will become sine. So I think I will have delta P1. That's BAK, na? Or rather delta P max. Let's say delta P max. Sine of kx minus omega t. Then the other one should be what? Kx plus omega t. So you have two waves which are represented by these pressure variations. They are moving in opposite direction, having no spatial phase difference or temporal phase difference. That means they are coherent. They are coming from coherent sources. They meet, and then when they meet, they follow what? They follow the superposition principle, and what is the final given to be? The resultant is given to be the addition of the two. And I'm not going over the exercise of how we used to find it. If you remember, this is sine A minus B, this is sine A plus B. You do the calculations, and at the end you find a peculiar feature. If you had the amplitudes initially A and A, then what is the peculiar feature about the amplitude of stationary wave? It becomes twice. है ना? 2A, I say 2 this sine kx cos omega t. I do not have any function of kx minus omega t या kx plus omega t. I don't have any speed here. ये याद है ना, यही फॉर्म होता था. This is my final stationary wave. I'm not going over the algebra. You can do it if you want. Okay. Then there were some discussions of nodes and antinodes. What was a node, by the way? Where the particles? They what? They remain stationary, he says. So the displacement is going to be 0 at that point. What about antinode? What about antinode? What was antinode? The place where your amplitude becomes maximum of the amplitude, because if you remember, I used to write this thing is the resultant ka amplitude, and that is a sine function. So let me write it. Again I will write nodes and antinodes, but since I have used delta p, so I will call it pressure node and pressure antinode. ठीक है? Pressure node. And what is the pressure node defined to be? What is the variation of pressure there? Earlier the displacement was 0, now what will be 0? The whole thing will be 0. Okay? So for all times, delta PR will be equal to 0. That means 2 delta P max sine kx will be equal to 0. That means sine kx equal to 0. And then what is the condition on kx then?
Should also be
No. In general, tell me what is the condition on kx? Should be equal to n pi. So kx should be equal to n pi. This is the condition on kx. And k can be written as 2 pi by lambda. And then what will you get? ये pi गया, and then you will get the positions to be n lambda by 2. What are these positions? These are the positions at which you will find pressure nodes. ठीक है? Positions at which pressure, so I am going to write pressure node Pn, ठीक है, exists. Is it okay with everyone? This is basically a repeat of what we have done in the interference of that, so I am not going over all the everything and just skipping through most of the steps. What will be pressure antinode then? बताओ, pressure antinode में your this thing will be a maximum, and what is its maximum value? This value. So 2 delta Pm sine kx should be equal to 2 delta Pm for all times. And if that cancels, then what is the condition on kx? What is the condition of kx this time? 2n plus 1 pi by 2, he says, and that's correct. Kx should be equal to 2n plus 1 pi by 2. Acha, I did not write it, but from where the n can start here?
0.
It can start from 0. N equal to 0, 1, 2, and all those things. What about here? The same thing, right? If you were to write 2n minus 1 pi by 2, then from where the n can start?
1.
It will start from 1. Is it okay with everyone? And if I write the k as 2 pi by lambda, x, तो बताओ xn क्या निकलेगा? n plus half lambda by 2. What are these positions? These are the positions of pressure antinodes. Pressure antinode axis. Is it okay with everyone? Please copy, and when you're done, then tell me. Everyone has written till there at least, na? Itna likho. And when you're done, then tell me. बोलो जो just for fun, can somebody tell me what is the distance between two pressure nodes? The distance between two pressure nodes, what it will be? Pi. Lambda by 2 is correct. What is the distance between two pressure antinodes? Lambda by 4. What will it be? Bolo, bolo. Lambda by 2 is correct again. Substitute and check if you want. What is the distance between a pressure node and a pressure antinode? The adjacent two. That's lambda by 4. Yes, it follows the same thing as before. Good. Now tell me this one thing, that what was, you already said it, but the main difference between a displacement wave and a pressure variation wave is that the phase difference is pi by 2. Yes or no? So if I were to make the graph, what will it look like? Let's say I have these two ends, and I have a sine like this and a cosine like this. A sine like this and a cosine like this. Let's say this is my y graph and this yellow one is my delta p graph. They have to be, so one of them is sine and other is cosine. Acha, nahi. What did I take here? In this example, I took the other to be cosine. This is sine, na? तो मैं इसका भी नेम चेंज कर देता हूँ. ये डेल्टा पी हो गया और ये डेल्टा, ये y हो गया. Then can you see where is my antinode situated for delta p? That's this, na? This is my antinode. This is also my, so this is also my antinode. At those positions, now tell me what will be the displacement just at this position. That will be 0. And displacement is 0. So that means when your pressure variation has a antinode, your displacement has a node. What about here? Again, so this is displacement node, this is pressure antinode. Yes or no? Now look at the other thing. Let's talk about here. What is this? This is a displacement antinode, and correspondingly what do you find? pressure node. So this is pressure node and this is displacement antinode. Is it understood kya? Ki they actually, if one exists as a node, the other exists as an antinode there. Remember that I am talking about this delta P here. I did not talk about the final pressure. At those positions where your delta P equal to 0, does it mean that the pressure there is 0? No, because what was the pressure of the medium, the final pressure? That was delta P plus P naught. So even if your delta P is going to be 0, you will have an atmospheric pressure there. You will not find vacuum out of a sudden, है ना? Vacuum नहीं बनता है, वो atmospheric pressure at least रहता है. Is it okay? Good. Copy the diagram. Once you're done with it, we can go on with some problems. Is it written? Can I give the question? And the diagram is something like this. Attempt. I am giving you 4 minutes. I will start at 1. What is the answer that you are getting? Should I start with the question? It was a very simple question, just single formula and you'll get the answer. You just have to remember what was the condition of constructive interference and find a path difference. So, what is the condition of constructive interference? I have written this for you. the path difference, which is S1p minus S2p, follows this condition of n lambda, I think. Yes, and that will put a condition on frequency as well. I think you have to find all possible frequencies ना. तो बताओ S1p minus S2p निकालो. S1p कितना है? 2 square plus 4 square 16 4 root 20 और इसका आंसर root 17 है. एंड स्पीड इक्वल टू एफ लैम्डा, तो लैम्डा इक्वल टू वी बाई एफ ना. तो यानी कि यू विल गेट समथिंग लाइक एफ इज इक्वल टू एन वी बाई S1p minus S2p. Please check my calculations. And then velocity of the sound is given to be 350 root 20 minus root 17. अब बताओ root 20 कितना होएगा? Root 20 can be written as 4 into 5, that's 2 root 5. Root 5 is 2.23, that's 4.46. अब root 17 approximately 4.112 4.123 ले लेते हैं. इज इट ओके? तो फिर ये कितना आ जाएगा फिर बताओ? 350 डिवाइडेड बाय 4.46 माइनस 4.12, व्हाट इज दैट इक्वल टू? ये 4.1 मुझे अच्छा ज़्यादा अप्रॉक्सीमेशन लग रहा है. ठीक है, तो ये 0.36 हो जाएगा आई थिंक, है ना. अब ये कट गया फिर, ठीक है. और ये कि बचा कितना? पावर -2 ऊपर गया, पावर +2, 1000 अप्रॉक्सीमेटली. ठीक है. सो व्हाट आर द पॉसिबल फ्रीक्वेंसीज? सो n starts from where? 0. तो यानी possible frequencies are 0, doesn't make sense at all, but the 1000, 2000 and so on hertz. Is it okay? Then what is the condition of destructive interference? बताओ, what is the condition of destructive interference? इसलिए I tell you to revise every day. These are things that we have discussed not long ago. बताओ कितना है ये? Delta x should be equal to I think n plus half lambda by 2, something like this, or n plus half lambda maybe. Lambda into n plus half, na? So that's root 20 minus root 17. N plus half lambda. Lambda can be written as v by f. So f becomes n plus half into 1000 basically, approximately. वही वैल्यू उतनी ही आ रही है ना. तो n starts from 0, so this is 500, 1500, 2500 and so on. These are the frequencies for which you will find destructive interference, and these are the frequencies for which you will find constructive interference. Is it okay? Yes? Copy fast. So these are single formula questions. If you don't remember them, तब तो मुश्किल है. I am not even complicating the questions right now. When you do come in the lectures of any kind of waves lecture, then revise all the waves that we have discussed. Wave motion be, superposition of waves be, and then come in the lecture. Lambda. लैम्डा बाई 2. अब खुद सोच के देखो ना बेटा कि अगर ऑड मल्टीपल ऑफ लैम्डा यानी एक वेवलेंथ ऐसा आ रहा है और एक के बीच में पाथ डिफरेंस कितना है? लेट्स से लैम्डा बाई 2 ले लेते हैं, तो लैम्डा बाई 2 यानी कि वो कैसा होएगा? तभी तो डिस्ट्रक्टिव होएगा ना। n प्लस हाफ लैम्डा लिया है मैंने, जहाँ पे मैं लैम्डा n इक्वल टू 0 ले लेता हूँ, तो यानी पाथ डिफरेंस लैम्डा बाई 2 का, तभी होएगा ना। तो यू कैन इमेजिन थिंग्स एंड यू कैन फाइंड द, you can make diagrams, find the conditions yourself at the instant. ठीक है? Can I write the next question? Please copy fast. Come. ये तो बहुत सिंपल क्वेश्चन है अगेन, बट मुझे लग रहा है अब बच्चे ये भी नहीं करेंगे। लेट्स सी हाउ मच डू यू रिमेंबर। इट्स लाइक अगेन अ सिंगल फॉर्मूला क्वेश्चन। Attempt. That's 60 degrees. जाओ जाओ। I will wait 2 more minutes and then I will start, okay? Should I start? Yes? Yes. Kilometer? Meters is correct. What about the second one? So I got one correct answer. Anybody else? Let me do it then. If you were to revise, you can instantly understand that it's a question of spatial phase and temporal phase. How far apart are 2 points? So there you're talking about 2 points. They are far apart by how much? If the phase difference between them is 60 degree or pi by 3 radians. So you're talking about at the same time 2 different points. Here you're talking about the same point at 2 different times. So that's temporal phase difference. So now it's very easy once you recognize it. Spatial phase difference is given to be 2 pi by lambda delta x. You have to find delta x. So that's lambda into delta phi s divided by 2 pi. V equal to f lambda, then lambda equal to v by f. And बताओ v कितना है 350. Delta phi is pi by 3. 2 pi. Frequency कितना दिया हुआ है 500. तो ये 0 0 गया, पाई पाई गया, तो यू विल गेट 35 by 50 इंटू 1 by 6. 35 by 50 कितना हो जाएगा 5 7 सा 5 10 सा, तो 7 by 6 इंटू 10 power minus 1. That's something like 1.116. That's 0.116 meter. Yes. और अब ठीक है, बी पार्ट भी कर देते हैं. You have to find कि what is the phase difference if you are looking at the same point at 2 different times. Then you are talking about temporal phase difference, and the formula was 2 pi by capital T small t. Yes or no? Capital T is 1 by frequency, so that will be 2 pi f into delta t. अब 2 pi पाई कितना है, अच्छा फ्रीक्वेंसी कितना है 500, तो ये हो जाएगा 1000 पाई और -3 दिया हुआ है, तो ये पाई हो जाएगा. Did you understand? Very good. So it was a fairly simple question. I am not even doing complicated questions for now. It's just a test of do you revise or not. We will do good questions when I give you sheets at the end of the chapter. This is just for fun. है ना? So I am not teaching anything more than this for today. You can switch off the video, and once you're done, you can take the break.